Hello, good evening, good morning, or good afternoon, depending on where you are in the world and when you are listening to this podcast. My name is Jamie Dobson, the founder of Container Solutions and the host of this podcast, The Cloud Native Attitude.
And I'm Ian Mile, partner at Container Solutions, where I work with Jamie solving real-world cloud problems with our clients.
Real-world cloud problems and being middle-aged, a journey we are sharing together. We are joined today by Sam Newman, speaking of middle-aged men. Hello, Sam.
Thanks. Hello.
So in today's episode number 5, which is called, well, we think it's going to be called Microservices, the Killer Horde, we're going to be speaking about 3 things. Well, obviously we'll be speaking about microservices, and we're joined by Sam, as it's fair to say the world's leading expert on microservices. But the first thing we really want to get into are use cases. What are the use cases for microservices? The second thing, which is, of course, my favourite and a bit of a running theme for the Cloud Native Attitude podcast, is capability building. It is really hard to build microservices, so how do we build the right capability to pull it off? And then the third and final part, which is going to be a little bit of a fight, is called why Ian is no longer talking to architects about microservices. So those are our 3 big topics, and as we get towards them, let me first introduce Sam properly. Sam, the most entertaining speaker in our community, bar none, a fellow rugby league fan, and of course the author of numerous books on microservices. Sam, how are you doing?
I'm doing well. I've just had a house move. This is not my normal setup. I'm now living quite close to the sea. So doing really well. I'm actually working on a brand new book at the moment on building resilient distributed systems. So once somebody's made you build a distributed system, how on earth do you survive that horrid situation you find yourselves in? And this applies to any distributed system, although obviously a lot of them are microservice-based things. So once the debris of the move is out of the way and I've finished assembling all the IKEA furniture in the world, I'm getting back to working on that book.
Sam, tell me, where are you in that process? You've got a title, clearly. Have you got a cover? Have you got a chapter structure?
A chapter structure. If you go to my website, you can see the current chapter structure. There's a couple of little tweaks we're going to be making to that, but you can get the broad overview. I would say I'm about I'd say just over a third of the way through the first draft. We're looking at it being in print January 2026, but the early access is already available for people on the O'Reilly platform. So you can go and read a whole chapter on timeouts, another chapter on retries. I've got a chapter on load shedding and back pressure, and one on the thundering herd, and they're all up there right now. So
amazing.
It's I've been really enjoying writing it. I'm almost thinking, like, my son's now about 4 years into his career as a developer, and it's like, if he was dropped onto a project that was already building a distributed system, what do I want him to know about to be able to survive that journey? And starting with the easy stuff, and then we get in towards the end of the technical side, it's going to be talking very quickly about consensus theory, but mostly saying read Martin Kleppmann's book. And then the last third of the book is all of the people and organisational side of making resiliency and the broader view of resilience engineering.
So in the Cloud Native Attitude, we have a chapter called Distributed Systems Are Hard. It sounds to me like you've expanded that chapter. Of course, that wasn't your starting book because you didn't write that, but it sounds like if people want a rough introduction to why they're hard, they can start with the Cloud Native Attitude, but as soon as your book comes out, they need to order that. And it sounds like a bit of an instant classic, Sam, I must say. I'm looking forward to seeing that.
Well, if they want to know more about it, if you sign up for my mailing list, you'll get updates as when it comes out. And if you just want to read what I've got now, you can do a free trial and read the early access stuff as well. I'm really looking for feedback as well at this stage. So if people want to give me feedback on what should be the book.
Feedback to take revenge on the consultant, now is the opportunity to do so. Now we're about to start getting into the guts of this podcast. Now, the Cloud Native Attitude, doing well, Sam. People like it because it's one of the only books out there that actually covers all the topics, not in depth, but in a broad sort of array. So if you want to understand why containers and microservices and Kubernetes and continuous delivery play well together, then you can take a look at the Cloud Native Attitude. But what that means is many of the listeners to the podcast or the readers of the book are quite new to Cloud Native. So I think we'd like to start, if that's all right, with what are microservices and why should anybody care?
Who's going to go first on this one? Ian?
You're the expert, Sam.
Yeah, you're the expert.
So I think there might be disagreement about what microservices are, but I wrote the first book on them, not because I'm the smartest person, just because I'm quick. And my definition, as far as I'm concerned, is the one that sticks. Microservices are independently deployable services. So it's a distributed system where these services themselves are independently deployable. Fundamentally, what we're talking about here is the concept of modular programming applied to a distributed system. So that's the distinction I make between the wider world of distributed systems and the microservices world.
Exactly. Now that sounds like the gospel definition because, as you said, you wrote the book. Now, just because they're independently deployable, does that mean they're independently runnable? Should every microservice do something?
If it doesn't do anything, why does it exist? I think there's a wider question. I often explain that all microservices really are there to be called, right? So they're there to serve something in general. I mean, there are some minor exceptions. A microservice by itself isn't a full application. If you can have a single deployed unit that is a full application, brilliant, fantastic, well done you. But a microservice architecture only really delivers kind of useful human-facing applications through these services all working together. And that's typically the challenge, is how do you get all these services communicating and working together without becoming so coupled that they become what we often refer to as a distributed monolith.
You said, Sam, if it doesn't do anything, why does it exist? But that's what people at Container Solutions say about me. Right? Okay, I've got a question for you. Claude Debussy said that the music was the space in between the notes. Is that true of microservice systems where there's multiple? Is it the interplay between the independent services that make the system what it is?
You could also call that a gestalt, right?
Yeah. Yeah, go on, Ian. What's your thoughts on that?
You're describing a gestalt. Like the whole is more than some of the parts. So you take the whole thing together, you've got a wonderfully working system, but it's the bits in between, like you say, the bits in between the services that make up the beauty of the system as a whole.
The sum is greater. The whole is greater than the sum of the parts. I think that's the thing about distributed systems.
Yeah, I think, but there's another aspect to this, which is, if we're taking that kind of Debussy quote more literally, the most interesting thing in a microservice architecture, and the place where you can screw it up the most, is in the communication between them. So what happens inside the box is way less interesting than the shape of the box, the interface of the box, and how that box communicates with other boxes. So I think the effectiveness of a microservice architecture typically lives or dies from an implementation point of view and from an architectural modeling point of view in those gaps, right? That is the most interesting part of it, really.
You've mentioned the modeling, Sam. One of the themes of this podcast, and it wasn't our intention, it just kind of fell out in the first or second episode, goes something like this. And it was all to do with a quote from a fella called Alad. Do you remember Alad? He started Accent. He's going to come on as a guest soon. And he said something.
Yes, we met, yeah.
Yeah, he's a Dutch guy, right? So he said something along the lines of, I don't build systems that work at scale, I build systems that can scale. And the point is that the lessons you learn along the journey between whatever the end destination is and where you are now are captured in the microservice, the communications protocols, and the sort of interfaces. And as you learn, those lessons get embedded in the system. Now, I don't know, is it an anti-pattern, Ian? We see companies doing Eric Evans' domain-driven design, working out where the boundaries are and saying that's a collection of microservices, and then being a bit annoyed that that's not exactly how it works out. Is that something you've seen, Sam? People trying to get it right first time, every time?
For me, there's a bit of a gap here about understanding. I think actually one of the nicest bits of framing I've seen around this was done by Simon Brown a few years ago. He did a great talk looking at modularity and distribution effectively, right? So he says you can have a monolithic application, which is a big ball of mud, it's a mess. Or you can have a monolithic application to put in one process where it's nice modules, where those modules could be domain-oriented boundaries, right? The question then is distribution. He makes the point that if you take a hot mess and distribute a hot mess, you've got a hot mess. So for me, the interesting thing about something like domain-driven design is applying domain-driven design to come up with my module boundaries. There's a separate conversation then, which is what about my business context drives me towards distributing any of those modules. And so I think what a lot of people do is they jump to distribution. They don't think enough about the modularity. And so for me, it's like the modularity is more important early on, especially early on, right? So
yeah, so
and then that I think that's the pitfall I see people fall into a bit.
And we're anticipating the fight later a little bit, but I think that's exactly the points I was trying to get to with my argument. And it was prompted by a talk by Ian Cooper, which I think you may be aware of, Sam, where he was talking about how, he was referring back to a book from 1975 called Distributed Systems Design or something like that, which I went off and read, and it has all the analysis for microservices already. I'd love to chat to you about it separately, but basically, it's just another kind of modularity.
Yeah.
It's
Okay. So as a rule of thumb, then the heuristic is start with the modularization and then think about the distribution later. Is that a fair takeaway, Sam?
100%. Yeah.
Right.
I'll share a link to Simon's talk because I think he does a great job of using that, and I use his framing now. Also, I would strongly recommend taking a look at some columns that Adrian Collier did a few years ago on the morning paper. He went back and looked at David Parnas's papers on modularity from 1971 through 1973. He literally crossed out the word module. He put in the word microservices. He read all those papers and said they make perfect sense. So 100% modularity, Uber, everything else really, and then distribution is what follows.
So there's nothing new under the sun. So for the viewer or the listener, we've got Sam's books, we've got the Cloud Native Attitude, we've got Adrian Collier's morning papers for those who want to learn more about the definition of what a microservice is, which of course now lets me move the conversation along. What are the use cases? Why do it?
Well, I've got the clients that I speak to, but you guys probably speak to way more clients than I do. So I'm actually kind of interested to hear from maybe Ian in terms of the conversations you have and why your clients are going after these things, or at least what they think the use cases are, maybe, and what you think the use cases actually are.
Yeah, so we find obviously the conversation comes up all the time because first of all, people we're talking to often use Kubernetes or are already using Kubernetes, and they think that having a container that's being deployed in a container orchestrator, that container or that set of containers is a microservice. And in many cases it is, in some cases, but they think they're already doing microservices, or they think they want to do microservices, and that's why. And this is one of the reasons I don't want to talk about microservices, or I don't want to use the word microservices anymore, because it gets very confusing and you get away from the real discussion. But what we find is that a lot of people mistake ends for means. So they talk about being microservice driven, wanting to move to a microservices architecture, and they forget the why. They forget the purpose of doing that. And if you look at a lot of what they're doing, it's not actually suited. Their business domain might not be suited to a microservices world. I used to work for a gambling company, an online sports betting company. We did back-end systems for bookies. And the whole point of that system was that the data was stored centrally in one place that you could very quickly get to that data in real time. So the idea of splitting this up into many different systems where data would move from one system to another in order to have a microservices architecture would have actually worked against that core goal of the system. So in that case, a monolithic architecture was actually quite appropriate. But many people in that company as techies were like, microservices is the way to go. Microservices is the future. We should be doing microservices. Why should we be doing microservices? Well, because it's a modern architecture. That's not a reason. And I think that pattern of thinking we see a lot.
I think from my perspective, the use case at least I saw maybe 5 or 6 years ago, are when you have a system. So imagine a web scale application, doesn't matter what it is. Some records are processed overnight. So you're recalculating an insurance quote or you're recalculating a ticket, you've got some federated data and something kicks off every 24 hours. Other stuff is dealt with in real time. And the type of development that would go into those services was different, required different skill sets, connected to different systems that different people may or may not have understood. So the idea was a combination of multiple teams that were specialized in certain things that together kept one piece of the jigsaw going, but when they were combined together, produced real-time web scale application. This I felt was a use case, but if you were doing that from scratch, I don't necessarily think you'd say, well, let's organize ourselves on specialist lines so that we can each manage microservices. I can't imagine it would go like that if you started from the beginning.
I mean, if I think about the use cases that I see, and I think the two most common, I think there are three use cases I'm going to talk about very briefly, two of which I think are incorrect uses of microservices, and one of which I think passes muster, in my opinion. The most common, if I see an organization where the developers are driving the architecture, the biggest reason given for microservices when you actually get through it is I get to learn loads of cool new tech, and I get to fill out my CV, and I want to learn new stuff. I actually don't think there's anything wrong with that as being part of a motivation. Master skills is important, but when that's the main driver for your technical strategy and it's done without any consideration about your business goals, that is a problem. It's also often in organizations where they give the developers no other opportunity to learn new things, which is a part of it. If I look at organizations which are adopting microservices and it's maybe more top down, or it's coming maybe from more technical leadership, where I think it's being incorrectly applied, and it's the IBM problem. I'm old enough to remember the phrase, nobody ever got fired for buying IBM. And so this was a situation where you just bought IBM software. Why? Because everybody else is buying IBM software. If I buy IBM software and it goes wrong, it can't be my fault. I've not done anything wrong because everyone's doing it. If I bought something that wasn't IBM software, or heavens forbid, wrote my own code and it didn't work out well, I was going to get it in the neck. So it's about, you stick with the industry trend, and it's about blame avoidance. And so from top down, we've got to be doing microservices. It's because everyone else is doing it. It's partly fashion, but it's also partly blame avoidance. And that's as problematic because, coming back to your point, Ian, it may or may not be connected to the actual business outcomes or the things that are most important. I think if I look at the larger enterprise companies that I think often have the best rational reason for microservices, it's not a technological driver. It's actually an organizational driver. So companies want to do more with the people they've got. They recognize that overly hierarchical organizations, you have that big fat middle management layer. They want to do more with the people they've got. They're looking at, how do I increase autonomy within my organization? That it's actually microservices as an enabler for an organizational change, I think is the best rational use case I see for microservices in scale-ups and enterprises. I think there are other things around the edges, like people often say scaling, but there's lots of ways you can scale a monolithic application. Microservices may or may not be part of that journey. There's some good arguments about resiliency and security as well, but I think they kind of tend to be a bit niche. But if I think about the most common good use case for microservices, it is that we want an autonomous organization, and so microservices are enabling that change.
So that's commonly also referred to as reverse Conway maneuver, right?
Yeah, that's my old colleague Evan Botcher's move, and it's not really quite, because the original reverse Conway is, you can't get, no one wants to do the organizational transformation, and so you create an architecture and watch the organization morph around it. So that was kind of, that came out of a conversation from
my
project I was
elevator
on
pitch
around
when we
that.
were starting container solutions went something along the following lines. So the most powerful software development method that we know of is basically open source, right? Where we use repositories. Git nowadays used to be something different in the olden days. Bulletin boards. We send pull requests to each other, to people we've never met before, and collectively this open source software comes together to produce stuff that's awesome. Although I can't think of any examples now. What's the most famous open source product, right? Linux. Right?
I'd say the Linux kernel.
Yeah.
And so
It's probably the most successful.
Yeah, and so each of those teams or each of those individuals looking after a part of the open source stack would, some of them might use XP, test-driven development, might use continuous delivery. Now, bringing the open source way of developing software into a large organization would be a really good idea for exactly the reasons you said, Sam. Get rid of all of that extra management and middle management layers. I always felt microservices help with that. If you had a team that looked after a family of microservices, they were good programmers, they had a good method, and we could send changes to them either as change requests or pull requests, then you start to get what looks like the open source model for development within the organizational boundary.
I think I agree in the sentiment. I think the reality of true internal open source is a little bit different. I think one of the interesting things is that really open source software development is primarily structured around untrusted committers. So you have individuals rather than teams. That's the first thing. So it's very individualistic based, and there's a lot of vetting that has to go on, especially kind of how it's done nowadays, because fundamentally people's work has to be checked. And so I like the idea in general around that model. But what I worry about is people transplanting that same model inside organizations, right? There's no need to do feature branch-based development, which is really about checking for untrusted committers, right? So I think the spirit is absolutely there.
You say that I would trust a random person on the internet more than I trust some of the people I've worked with.
Well, I mean, given that you've hired some of those people, Jamie, I think that only points the finger of blame in one direction.
The thing is, it is a noble sentiment, and it's a sentiment that makes sense, but in the 10 or 12 years I've been messing around with this, I've seen it pulled off exactly 0 fucking times.
I would caveat
here.
that. I think the internal open source model, I've seen it work only when the capability of the organization, technical capability of the people in the organization is very high, and their understanding of the mechanisms of software collaboration is very high. But for most people, it doesn't. It off.
Well, that does bring us to the second part of this podcast, Ian. You've brought us up to it perfectly, actually. What capabilities do you need? Because I think it's fair to assume when you start to list all the things that are involved in microservices, such as contract testing, modularization, the programming of the service itself, it requires a very highly capable workforce. So what is the relationship between microservices and capabilities? And if you don't have the capability, should you just give up? Or what do companies do at that point?
I mean, I would sort of categorize it in two ways, right? There is the skills you need to build and maintain a distributed system, and that's one bucket of capabilities. And in general, as your system becomes more distributed, you need to get better, right? If you've got one or two things, you can manage it. If you've got one or 200 things, if you've got one or two, a couple of thousand things, your capabilities as an organization will need to grow accordingly, right? So that's the distributed systems bucket, right? The other bucket is the architectural discipline to define and continually refine and maintain modular boundaries. And for me, they're two separate buckets of skills, because one's about architectural and developer discipline and does not involve cat theory, which I always get excited about anything that doesn't involve cat theory, right? The other bucket is we've now decided to distribute, and we've now got to work out like what is a good timeout. How do we handle something falling over our platform and everything else?
It's fair to say that both of those are quite mature capabilities, and you need both to succeed, right?
Yeah.
So then, what chance of normal average businesses out there have succeeded with microservices realistically?
Well, I think lots do succeed. The question is, are they succeeding in spite of or because of? And I think actually one of the areas around the modularity where things get quite interesting, and this really comes back to Conway's law and to a large extent where Eric Evans talks about, if you think about how our main structural unit of organization within a domain model is the bounded context. What's the bounded context traditionally driven by? Largely organizational structure. So actually, if you think of it from that point of view, if you're letting the organization drive this is my big box of stuff, you do get a bit of a head start on the modularity side of things. And so I think if people get to that kind of, this is your box, that's your box, that's your box, I think that helps a little bit in terms of at least maintaining that discipline then around this is your box of crap, right? And then what you do inside your box of rubbish is kind of up to you. I mean, the reality is a lot of the stock conversations about modularity are actually quite simple. And when you start talking about the terms related to structured programming, people know what these terms are. It's just that they've got lost in the morass of everything else. When you say, do you know those words coupling, cohesion, encapsulation? They all come from information hiding, the work done in the late 1960s and in 1970s. A lot of these are ideas which the developers implicitly know, but don't explicitly kind of dig out again. And I think that framing, I think that really, really helps. I mean, this is also why, again, talking about prior art, you should really look at the ports and adapters pattern by Alistair Cobert, which is basically taking the concept of information hiding and applying it in the context of distributed systems. The other name for ports and adapters pattern is hexagonal architecture. And that's why I draw microservices as hexagons, right? There's actually some really, really simple basic ideas there that really do help. And then that bucket of distributed system capability, I always say, you start with one microservice, right? And then you work out how your organization does one. And then you go two. Don't copy what Monzo do, right? Where they've got, 20 microservices per developer. Most aggressive ratios I've seen of developers to microservices. They went on a journey to get there. That's not your journey. Your journey starts with one. You see what happens, grow from there.
So what is the relationship between, or what is the overlap on the Venn diagram between microservices and object-oriented programming? So we used to talk about highly cohesive classes that were loosely coupled together. That kind of sounds like a heuristic of microservice architectures too.
Yes, there's definitely overlap. So I would say that the commonality here is around coupling and cohesion. So this is back to the old Constantine's law stuff. In object-oriented programming, you talk about encapsulation. That's basically an example of how information hiding is applied. There is again a little bit of a slippery slope you can go on. If you sort of start saying that, you can just start treating every object like every service like it's a big object that's distributed. Martin Fowler's first law of distributed objects is don't distribute your objects because they tend to be way too fine-grained. And I think coming back to the point that we talked about earlier, just because something's a nice boundary doesn't mean I should distribute it. But definitely the things that we would have learned from object-oriented programming classes and everything else, coupling, cohesion, encapsulation, will stand you in very, very good stead. And I think, again, that's how you go towards modules. I think actually, honestly, a big problem we've got, and the reason I think the modularity stuff is so difficult, is our programming languages in general do an extremely bad job of giving us capabilities in the language themselves to define good modular boundaries. And so they often are a weak concept in how we structure our code.
I wonder. I could see Ian flinching. I'm going to do it there before he does. I honestly think so. I've just had lunch today in Canary Wharf with a friend of mine, and we got talking. She fell into management, in a bit the same way I fell into management. I'm not a manager, but I was able to do one thing, I think, that nobody else in my team could do, and they're all really good computer programmers, all really, really good programmers. They couldn't put things in boxes. Not for the life of them. It's like, is a continuous delivery server up and running? No. Well, let's do that. Oh, that's a good idea. So I was putting the project in boxes. Have we got a build script? Do we have a plan? Should we put a plan on the wall? And then the next thing was, okay, we've got this massive, bearing in mind we were all Java programmers, massive class with loads of methods, and it gets passed to this, passed to that, passed to that. I said, okay, that looks like it's parsing a message, so let's pop that in its own object, so we'll wrap it in some tests for the CI service. And then what about this? So you say the languages are at fault, and I'm thinking maybe, but I reckon the way people think is at fault. And I think doing boundaries of any kind is extremely difficult for most human beings and almost impossible for most programmers. Am I
What
wrong?
are your
Am I
thoughts on
crazy?
that?
No, I think you're right. I think this sort of discipline. So my mind's racing because I'm thinking of so many things. I was thinking about how object orientation made explicit the things that were implicit to people before. So programmers started by typing in a series of commands. Then they put that into a file, and then they thought, well, let's have multiple files, right? And then you got the boundary there, and that was good enough for most people, and it's good enough still for Python and lots of things that we use day to day. But object orientation said, no, let's make this formalized. Let's formalize this into objects. And when I was starting in the industry, around 2000, you had to learn Java. It was the thing to learn because object orientation was the future and everything was going to be a fully object-oriented language. And then as I got to know Java better, I found that I felt it constrained me from moving quickly and building stuff well. And I joined a company that used a scripting language. And that scripting language allowed you to do all these horrible things. But the people who built that code did it in such a way that they didn't allow those leakages to happen so easily. So you ended up with a system that was effectively quite modular, but it was harder than in Java. It's easier in Java. The other thing I was thinking was, I'm sure you're familiar with a language called Erlang, Sam. And to me, that's the ultimate modular language. And it makes it very easy to think about things in the right way, because every single module that you create talks to every other module over the network. And has you cannot reach into something else and change it.
Because in Erlang you have subscribers and publishers. Is that the model that you're
Well,
in
it's because Ericsson created Erlang specifically for programming telco switches and things like that, where you need to be able to hot swap modules. So they formalize the concept of modules, not just from a programming concept, but also from a runtime concept point of view. So it's a big formal part of the language, right? In the same way, object-oriented programming language is, I think you put it really nicely in. You make the implicit explicit. I think the modular concepts are not explicit enough in the majority of modern programming languages. We sort of stumble into it around package management, right? So I think Erlang's a great example. Now, if you look at what Java's been trying to do with the Jigsaw program, which has been going on for a lot of years now, the original goal was to get to hot swappable modules, proper hot swappable modules, like we can in Erlang, like you can in a lot of mainframe-based systems. The really interesting thing is, if I've got a single process which consists of lots of modules, and I can robustly hot swap them, I don't need to necessarily distribute them. The only reason to distribute them then is because I need new computing resources or an isolate failure planes or a data location, right? So if I've taken out if I don't need to distribute them, I can now have more monolithic software, but allows me to hot swap, which in turn gives me independently deployable modules. So I'm hopeful in 5-10, it won't be 5 years because Java goes too slow, that 10, 15 years out, we'll have more runtimes like Erlang. The issue is that the Erlang runtime is niche. It's not got much support behind it. I mean, there's some interesting stuff on top of it, but
I honestly thought Erlang didn't succeed as a language because most people were not smart enough to use it.
Well, you've got Elixir, right, which is basically putting a Ruby syntax on top of it. A lot of people love that. And it's still huge. I mean, RabbitMQ is written in Erlang. It works, but it's not accessible. And despite a lot of people putting a lot of hard work into it, it hasn't. I think the module side of things is really robust, but retrofitting that into an existing programming language is really difficult. And I strongly suspect that the original goals of Java's jigsaw
I
program
don't think it can be retrofitted to Java. Java was originally invented for set-top boxes for televisions. So when you scroll through Sky and you choose the channel or you record, so the virtual machine, the idea that you wrote your Java code once and it ran everywhere was because you'd have developers building those user interfaces for televisions, and then they could be distributed onto set-top box depending on who your TV provider was. And then Oak, which was the original name, had to be changed because it was already taken as a trademark, and they called it Java because of all the coffee the Java team drank when they were deciding the language.
I mean, it's retrofitting it is possible if you change the JVM. Retrofitting it is not possible if you don't do that. And there's a project called OSGI which has attempted to do that for a long time, and it failed because it couldn't robustly do it. So if you really want to do it inside the JVM, you have to go and change the JVM internals. And that's why, unfortunately, it's going to be something that we're reliant on Oracle for. Oracle know how to make money. Sun knew how to make good technology. We've lost something along the way there, I think.
Right. Okay. So now we're going to exit this part. We can't speak for too much longer about Java. We're going to lose anybody in our audience who's like under 33 who's already checked out by now. Okay. So let's just summarize. What are the use cases then? So we spoke about large organizations, Sam. That seemed to be one of the key use cases for microservices.
I think organizations where you want to improve organizational autonomy, you've got lots of people that need to work on the same application and you want them to improve autonomy. I think microservices they can be worth the effort in that situation.
Fine. Okay, so let's move on to our last subject, which is a very, well, I don't know if it's controversial, but Ian wrote a blog, Sam, that's doing very well. And it's called Why I'm No Longer Talking to Architects About Microservices. Now, Ian, why don't you give us a recap of what is your central thesis and exactly what is the bee in your bonnet?
Yeah, so I mean, it's terribly ironic. I wrote that piece and now I've talked more about microservices in the last week than I have in the last 20 years. But it was triggered by two things. One was I saw a talk, as I mentioned, by Ian Cooper, which was about microservices, and it triggered all sorts of thoughts in me about my relationship with the term. And also I was in a meeting and a bunch of architects, I don't know, what's the collective noun for architects? I'm sure we can come up with something good.
An inefficiency?
No, it's a parliament of architects.
Parliament of architects, there you go.
So I was right when I said inefficiency then, wasn't I?
Inefficiency of architects.
And someone said something about microservices architectures, and then we went down a rabbit hole, and it added little to the discussion. So I have three problems with microservices, right? The first one is no one agrees what microservices means. And Ian Cooper had a whole list of different terms, but Sam's explained what it means, and we all accept that definition as canon now. The second was that when you have microservices conversations in those kind of meetings with architects, you tend to lose sight of the business goals you're trying to get to. And the word becomes this thing that you're focused on, and also, as I say, everyone means something slightly different by it. So you don't necessarily get the same. You might be talking around it, but not actually usefully talking around it. And third, and you've touched on this already, Sam, adopting microservices without considering your organization is pointless. And a pattern I've seen with a lot of architectural discussions is that they don't actually think at all about the organization. They're just thinking about the tech. And I think that goes back to the first use case you described, which is devs trying to use cool new tech, right? Which is another way to put it. But yeah, those three things triggered the discussion.
And just to reiterate, often microservices are a symptom. If a microservices architect is being picked because developers want cool new tech, then what the microservices are a symptom of is that organization is not creating an opportunity for those developers to learn new technology. So the problem should be that you should solve that one. I agree with many of your points. I think it's really dangerous. The phrase I use a lot is your users don't care about microservices. Your boss probably shouldn't care about microservices. The programming language that your system is written in is completely and utterly unimportant to the people that use your software. It's as important as a conversation about tabs versus spaces, and microservices are an implementation detail. So what your users care about is, does the software work? Do I get new features when I want new features? Is it fast enough? Is it robust enough? Is it speedy enough? Can I use it when and where I want to use it? That's what they care about. The problem, though, is when you frame any work you're doing in the context of microservices, then you're viewing microservices as the answer. The answer to what? It's the underpant gnome thing all over again. Step one, still underpants. Step two, step three, profit. It's like step one has become microservices. And it's like, I'm not going to lie, lads. It keeps me in business. But, I don't want it to happen. So
Maybe we should write a blog, Why I'm No Longer Speaking to Executives About Microservices. Because we literally meet businesses with executive teams with C in their title, but not the chief technology officer, Sam, who want to talk about the Amazon tools we're going to use, the microservice architecture we're going to build. These people have never been near a computer in their life, let alone program one. And it's like,
But this is
why are you asking me about
this is back to the
implementation
30.
detail?
This is the conversations I had 30 years ago when I first started as a developer. People want to buy IBM software because everyone else buys IBM software. They're buying IBM software, so we should buy IBM software. And you got to peel it all back. It's like, as a business, what are you trying to do? What can't you do right now? Well, let's do something to achieve those outcomes. Microservices are in the mix with everything else. A lot of the common use cases that are thrown at me for microservices are like, oh, I want to scale my application. Okay, great. So your target is, that's an outcome we can talk about. Scale, we can talk about that. Okay, what scale do we need? Where's the bottlenecks right now? What are your targets? Let's look at those different load profiles. Great. Have you tried putting your current monolithic application on a bigger box? And they're like, you shouldn't do that. And it's like, you absolutely should. Because if you can get your system to scale really quickly just by changing instance size on AWS, do it, high five, go home. And then you buy yourself time, right? People are so like, or running 2 copies of your monolith behind a load balancer, right? It is deeply unsexy and deeply, deeply efficient, and in a lot of the cases, completely viable. But the moment you make it about the mechanism or the implementation detail, you can't challenge yourself internally about, is this the right implementation detail? Someone goes, I've just got the go ahead to do a 6-month microservice transformation. If 3 months into that, you realize microservices are a terrible idea, once you've got that, you've gone and burnt that internal capital, getting that budget, getting that sign off, are you going to go and say, we made a mistake, we're not doing microservices anymore? Of course you're not. You're just going to keep quiet and hope it's fine. I have worked with more than one client where the main reason I was being brought in was to basically justify why they weren't doing microservices and give them air cover for that decision. But if you say, no, we're operations, scale the system, and then you start, that makes you honest. The outcome is scale the system. Let's list out all the ways we can scale the system, and we start with the easy one. And microservices are never the easy thing.
So
I refer to microservices as an architecture of last resort.
the architecture of last resorts, that's a great...
Try everything else first.
Maybe we should rename the podcast The Architecture of Last Resorts. So,
I like
Sam,
it.
you make a brilliant point. Two episodes ago, we spoke about context, why context should drive decisions. And often people don't understand context and they do stuff because they think it's sexy. So you end up with leaders who cannot frame the problem. So as you've just said, we might be framing it in terms of scale, speed, time to market. But you should no more be talking about AWS services or microservices as you would be the type of keyboard your programmers are typing on. It's bonkers. And the big challenge is when programmers or anybody promoted to that C position from within the organisation, it's an issue because they don't have that external viewpoint and they're not used to the reframe.
So I think some people would be really shocked, Sam, that you would say, why not just have a bigger instance? Because I think engineers get bewitched and people of an engineering mindset get bewitched by elegance. And I used to always say to my teams, like, are we here to make elegant software? Are we here to make money? And, there's dangers to that argument. I know that. You keep making inelegant software and you can end up in a situation which is disastrous. But people, as I say, people lose sight of that basic goal.
Okay, so I think that's a great place to end, guys. People lose sight of the basic goal. They misdiagnose the context. So I think these are the things we've learned. We've learned what is a microservice architecture, and a microservice is an individually deployable unit. We've learned that microservices collected together in an architecture are the architecture of last resort, and you shouldn't be using them because they look good on your CV and they're sexy. But we also learned at the top of the podcast that distributed systems are really hard, and Sam has been working on a new book about that's going to be coming out soon. So on that happy note, I would like to tell the listener that the next podcast, episode 6, is literally called Why Distributed Systems Are Hard. So a lot of those themes that Sam mentioned earlier are going to come back. On that happy note, I'll say thank you and goodbye to Sam.
Thanks, Jamie. Thanks, Ian.
Thank you and goodbye to Ian.
Thanks, boys.
And thank you and goodbye from me. I've been Jamie. We'll see you all next time.
Bye.